To get a better understanding for us about the overall process of the data preprocessing and what will it produce a good training data for the actual machine learning. So let's have a look on the data that we get from the Kaggle. Kaggle is a website that usually having some dummy data or even real data that already been processed, and we can use the data to become the exercise for us to running a certain machine learning model. So let's say this is the data from the Titanic. What happened to the Titanic at that time is one of the worst transportation tragedy ever happened. In the case that because it's happened uh, with a larger scale at that time, I'm not sure that they have this type of detailed data. But then Kaggle trying to recreate at least some of the information from the Titanic, and I add some name to represent the movie and not the actual accident incident. So let's say we have this information for the Titanic. So we have the number of passenger, we have whether the passenger is actually survive or not from the actual accident, and what is the class, and who's the name, or whether it's male or female, what's the age, or whether they have a sibling or spouse in the ship, or what is the parts number, what is the ticket number, what is the fare, which cabin they're on, and where they embarked. So this is the code from the city where they embarked. So this is usually what the raw data is, and depending on which type of the machine learning and which type of information we want to get, we will process the data differently. Let's say if you want to look at the clustering, uh, there are several cases where most of the data will still be there, except for several of the unwanted one. But when you work with the classification, you will cut some other data and keep the other data. In this case, usually if we have this type of data, we can make a dummy assessment on which attributes from the passenger of the Titanic that led to their survival on the incident. So let's say we have a passenger ID, we have the survive or not, we have all the information. But if we want to predict whether a certain passenger is survived or not, the second data, which is survived, is what we call the label. So we omit the data from the rest, and we use 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 other data for the attributes. So the combination of the value of the attributes hopefully will give us enough information for predicting whether a certain individual is survived or not. So that's the idea of classification. And of course, it's based on the data. As long as we make sure that our data have a good distribution, and it's replicate the real pattern in the real data. The real data means the unknown data. We can say that, okay, we can train our model using this data and expect that when the other data coming, they will behave similarly to this data, at least for the Titanic scope. So let's talk about the demo of our Titanic data training. So in this case, I'm using Python and some related models like the sklearn, NumPy, and Pandas. But there will be another module that will be usable in other programming language. So usually with this kind of data, if you have your computer, most data scientists will use either Python or R. But because you're working with the application development, you will need to use another machine learning module that available in the programming language that you use. So we start by importing, sorry. So we start by importing some modules from using to the Python. So this is the story about the Titan again. The 1912, the British passenger, blah 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 blah. This is the story, but the most important thing is the attributes. So this is the attributes. This is the description of the attributes, and the combination of these attributes will lead to what we deduct as the survivability of the passenger. So we can say that although some of the information is we can say that it has a certain impact of whether one passenger is survive or not. Let's say about the age, let's say about the number of sibling or spouse. um, we can see that there are several other attributes that is actually really hard to be what's called notated as a number. So let's say from the passenger ID, so most of the database they will have a unique ID, but in this case the passenger ID won't be useful, and it's also with some information, let's say ticket ID or fare, or maybe if you want to see whether the one that pays less is actually have the more difficult life, that's why they are stronger and so on, you might be able to do that. But yeah, depending on the available data, it might be useful or not, or yeah, something like that. So this is the data, the Titanic data, and if we run the information, we can see that this is the basically the summary of the Titanic data. Okay, we skip from 9 to 881 because I just want to know the top 10 and the bottom 10 of the data. There is no other information. It's because it's too big to display all of it. And mm, okay, so if we want to train, remember how to train the machine learning, how to train your machine. So first you get the data, check. Second, you remove the unusable data. And let's see, what can we remove? Passenger ID, maybe try to remove that one. Passenger class, let's see. Maybe the first class will get the more priority in the boat, or maybe like that. Name, yeah, name is very hard to be explained using a number, and we don't think that the name has something to do with the survive or not from the passenger. Unless your name is Jack Dawson, you will die by the end of the movie, or if your name is Rose Bucatier, you will survive, or maybe your name is Mr. Barry Allen, you will be able to run on the water and you survive, or something else. But the idea is a special case is not representing the whole data. So we can say that, okay, the name will be gone and so on. Male or female, we can say that in the movie, at least, the female and the elderly, they got the space in the ship, the small ship, but not the other one. So yeah, so how about the age and ticket number will won't matter in this case. And there is another case when the cabin, so because after the incident people won't think about the cabin, it's just like, oh, just want to whether you are survive or not. So a lot of empty data in here. So what we can do is, let's say we only take several of the information. So what is the passenger class, what is the sex, what is the age, how many siblings spouse, what is the parts, maybe because the some of the parts is located in the bottom, and some of the parts is located somewhere that easier to look for the safety. And maybe the fare here, when the highest fare might have the more priority in the safety boat, where the lowest fare maybe have the stronger physics for so on. And the survive here is the overall result of this whole incident. So when we work with this one, you can say that from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and one label, we cut down into 1, 2, 3, 4, 5, 6, which is around half of it. So that's the second step. So we got the data, we we managed to have some of them uh, cut from the actual calculation. So we come to the third step. So machine learning, if you remember, work with the number. So we need to change some of the non-number into the number. Yep. Okay. Oh yeah, before there is a called the drop not available. So we already cut the data, that incomplete data. So if somebody have some information that incomplete, we delete all of it. So in this case we want to change this one into a number. It's not about the which one is 0, which one is 1. It's just to separate them into the numerical value. So in this case we use the label encoder. So basically they will look how many distinct features on it, and they will start naming the feature 1, 2, 3, 4, 5, or 0, 1, 2, 3, 4, 5 until the end. Okay, so yep, now they labeled 1 at 0. So now we are ready to use this information into our machine learning model. And how about the normalization? Yeah, normalization usually happen in the unsupervised learning. In this case, this is a supervised one, which is, yeah, we don't really need the normalization unless it's necessary. So we just put it on our model. So the idea of the model is, we first split the data into what we call the train and test. The test data, it's also called the validation data. So what is the test data, you ask? So imagine that no matter how big is your data to train the models, the real usage of the model is to predict the unknown information that will come later on. So we need to make sure that the model learn about the generic pattern without memorizing the answer. Memorizing, or we call here overfitting, means that instead of looking at the pattern, the model start looking for the exact combination of a certain output. So what we call overfitting is the model might get 99% of the training data. That means they learn it, and when they check, they predict it's correct, but it's really low on the new data that's coming. So that means the model won't be usable anymore. So to prevent that from happening, we use what we call the test set or the validation set for some people. So we split 80% of the information of the Titanic is used for the training, and the rest of the 30% for the testing. The testing, the machine won't learn anything from the testing. It just check whether the testing is still okay or not. And then we use one model called the logistic regression, and we train the model, and that's it. So we can see that a good model will have a decent result after so much iteration. This one, the maximum iteration is 1000 iterations. So after some iteration, the model will have at least a decent amount of the correctness in the training, and to make sure that the model is not memorizing anything, they will also need to get the good or at least decent amount in the validation. So when we run this model, oh sorry, okay, sorry, I mean forget to comment this one. Yep. So you can say that the training score is around 80%. So that means based on the information that the model learned, they manage to learn a pattern and predict the correctness close to 80% with the data that they learn. So and for the testing score, for the 20% data that they never know and they never learn about it, they manage to predict about, yeah, or close to 85%. So it's still okay. So the, the the important thing about this one, the machine learning based on the mathematical model, and it's also based on what data you do. So the trend test split is basically split the data randomly. So a different data will cause the model to behave a slightly differently. So when we restart the experiment, you can see that some the value of the training and the testing score might change a little bit, but as long as they're not skewed toward one of them, in this case a really high training but a really low testing, it should be okay. So that means the model is working correctly. So in the end, what is the final goal of training machine learning? In this case, is a prediction. So let's say we want to predict whether a certain unknown passenger is survive or not. Let's say they come from the lower class income. It's a male, 20 years old, zero relative, and the fare is $10. And in this case, they make the input as it is. So we got the information, we got the input, and let's see whether this one is predicted to be dead or survive. Yep, unfortunately, it's not survived. So yeah, the machine learning, it's just in this case just a prediction, although it might be correct or incorrect. The correct rate is around 80%, which is good enough. So yep, that's how you use the machine learning to work with the data processing and then training the model. So I hope this short crash course is usable for you, whatever your project is it. And if you have any other questions, you might be able to contact me. I will be ready on Saturday, hopefully. And yeah, have a good luck on your project. Thank you.